Hey, Subspacers, I'm Ryan, and today I want to give a really quick high level overview for any newcomers of the basic ideas and principles of subspace. And if you want some more detailed technical explanations, we have some great resources linked below. So let's get right into it. So, new blockchains have emerged implementing a traditional proof of storage consensus. And this is where a user dedicates a part of their computer storage to maintain the blockchain, and in return, they gain rewards. And we call these users farmers. But here's the tricky part: farmers have to make a hard decision. Do they help maintain the blockchain history, or do they want to maximize rewards? And between you and me, I would want the most rewards, and I wouldn't really care about the blockchain history. And this is how we think a rational person would think. So the traditional proof of storage consensus can lead to an unraveling of the blockchain history. So to solve this, Subspace presents the proof of archival storage consensus, which we also call the lithium. And the way this works is through a distributed storage network called DSN. So each farmer node stores parts of the blockchain history, and based on how much storage is dedicated, farmers store as many copies as they can of different portions, and in return, they receive subspace currency, which we call SSC. So together, all the farmer nodes store multiple copies of the entire history, and thus we can all agree on what's on the blockchain because the history is spread across all the nodes. But there's also more problems, and that is state and blockchain bloat. Essentially, as the blockchain grows, the history also gets larger. And it gets to the point where the storage required to farm is just simply too high for the average user, and the user gets less rewards. So, as an average user with an average hardware setup, I will want to join a centralized farming pool, which is where users collectively combine resources to farm efficiently. And basically, this causes a pressure to centralize because I don't want to farm by myself. I want to farm with other people. But then all the power gets centralized into one entity. And that's something we want to avoid as a decentralized organization. And that is our thinking. So, to solve this, we present the coupled execution system, where essentially we separate the consensus of the blockchain as well as the execution of transactions. And so, I'm going to introduce two different new terms called operators and nominators and tell you how that involves the coupled execution. So operators are the ones who actually execute the transactions that come in. And so the way they do this is they have to stake currency to win the right to execute their transaction. Staking currency is when you lock up your currency to participate in execution and domain block production. And by doing this, you get transaction fees. And the system of staking also provides a crypto economic security because operators who have bad intentions and try to ruin the network lose their stake, making it financially inefficient to try and ruin the subspace network. However, operators require a really good hardware setup, like more advanced than most farmers. And so to work around this, we want to give farmers a way to still participate in the staking. So we have what we call nominators, and these are farmers that nominate or vote for operators by staking with the operator. And so in return, they get a portion of the transaction fee earned by the operator they have nominated to. So we call this a nominator stake, and this is included in the overall operator stake. Operators are chosen based off a staked election process. So the higher the stake, the more likely they will be selected to execute a transaction and earn a transaction fee. So the more SSC staked by the operator, as well as the more nominator stake they have, the better and the higher chance they have of getting a transaction fee. So how does this play into the big picture? I want to run through an example transaction really quick, just to kind of show you what goes on. So let's say first the user submits a transaction to operator. The operators are then elected and then bundle these transactions. These data bundles are then sent to farmers who will verify the election and verify that the data is available. And then they'll turn these bundles into blocks. And then the ordering of the transaction is determined by the consensus that the farmers provide. So then the operators then execute transactions based off the order. And so by separating this execution from the consensus of the network, Subspace is able to scale without encountering state and blockchain bloat. I also want to introduce the concept of domains, which are really important to Subspace. So domains are like smaller specialized sections that sit on top of the larger Subspace network. And these domains can be basically thought of as like L2 rollups. Each domain acts as its own little blockchain, but relies on the main Subspace blockchain for key functions like consensus and settling transactions. And so domains make it easier for developers to create their own layer 2 blockchains or dApps within the Subspace ecosystem. These domains also allow for seamless integration with other networks and their virtual machines, such as the EVM, the Ethereum virtual machine. And so Subspace actually has an EVM domain called Nova. If you guys want to check it out, it's down the link below. So this means that any decentralized app built on any EVM compatible blockchain can actually be imported onto a Subspace super easily, which allows for a really unified blockchain ecosystem. So I want to put it all together. How does everything come together in the big picture? So at the bottom here, we have the consensus layer, which is what the lithium or the proof of archival storage works on. And then we have the execution layer, which is how operators, nominators, that's where they do all their magic. And finally, we have the application layer at the very top, which is where developers can build dApps without having to worry about all the backend details of the blockchain. And so to kind of recap, Subspace aims to solve the farmer's dilemma through proof of archival storage, also called the lithium, and they also seek to solve state and blockchain bloat through the decoupled execution framework with operators and nominators. And so all these solutions allow for extremely scalable and inclusive blockchain that is Subspace. Thanks everyone, and please leave any comments and questions. We're always available on Discord, so feel free to reach out to us.